Hello everybody and welcome to another Labview related lecture. What I want to do today is talk a little bit about Labview VIs that will be useful for the assignment. And I may have covered some of this before, but I'll just go reiterate a little bit. Now the first one I'm talking about here is iMac read file. So this is where you're reading an image in from a file, and this is the file path. As you can see, this green line here. Then the image comes out and you can see that the image is out there. Now you notice that this green line is thinner than this mauve line here. That's because this is just a small amount of information, the file path, whereas the image contains a lot of information, being an array of each pixel value, of course. So in Labview we talk about it being clustered. So there's lots of values here clustered together, a bit like in a factory where you'd see lots of wires collected together into a big plastic pipe maybe, and that would be a cluster of wires. So that's the VI for just reading in from a file. Now we have to tell it what file path we want, and we enable the user to search through file paths and find what they want using, for example, something like a file dialog VI. This is an express VI, which is something that was invented quite recently by National Instruments and enables you to just really quickly and easily get open file dialog boxes. And again, when you're using this in Labview, you put the context help over it. It tells you all about what the different inputs and outputs mean and what you can do with the VI typically. Another one I've got here is a sequence structure. So this is a sort of structure type of VI, which means that you can control sequence of operations with it. Now it looks like a piece of film, and that's because it enables you to force control onto the way that the VI works. So it consists effectively like a real film of a series of frames, and each frame is done sequentially. So first frame, second frame, and this is good, especially if you're learning with Labview, that you can force some structure onto the way things are operating. Make sure this is done before something else. So you probably make use of sequence structures, I would think. Another type of structure, of course, is a while loop, which will do whatever inside that box until it gets a Boolean false fed into that input there. As you can see, that's all explained there. This other node here tells you the number of iterations that the loop's gone through. So sometimes if you want to cause a delay in a program operation, you can get a while loop operating for a certain number of times, say 100, 500 times, and you can put a little metronome type of VI in there, which basically causes a wait operation to occur for a certain period in terms of milliseconds. So 1,000 milliseconds would cause each iteration of the loop to wait for 1 second, for example. So that's the way you can delay things in a program if you want. iMac create, as mentioned, what it does is it allocates memory inside the computer to allow you to create an image, which you can then process and do whatever you want with. But if you didn't use it, you wouldn't be able to. You wouldn't be able to do anything with the image because you have to create the image, and that's what this does. Now, once you've done whatever you want to do with it, of course, you then want to remove it or get rid of it because you want to free up that memory so you can do something else with it. So every time you call iMac create, you should subsequently call iMac dispose, which will get rid of that, that memory allocation and free it up and get rid of the image. Sometimes people forget to do that, and if they keep creating images without disposing of them, eventually the system will probably hang. So learn the hard way if that happens, I guess. Threshold, you've already played around with that. So you know when you put a grayscale image in, you want to threshold it so that you set in pixels of interest to 1 and pixels of you don't have the background to 0. You create a binary image. Reject border, you might find this useful in the assignment. It just gets rid of any objects that are in contact with the border. So when you're using context help with these VIs, if you want to know more just than the general summary, then you click on here and it comes up with information on the inputs, the outputs, and other useful information. WinDraw is the way that Labview displays images typically on the screen. In fact, it doesn't display them directly onto the front panel. It creates a window and displays them in that. That's the way they seem to have done it. So this is the simplest way, just as like that. And as I might have mentioned before, it's pretty important when you're displaying an image using something like WinDraw that you tell the system what kind of image it is. And the best way of doing that is to just use the iMac get palette VI, which will then have an output coming from it, which you can control, like it's a grayscale image, a color image, a binary image. You can control it, and the cluster comes out of color palette there and is fed into the iMac WinDraw. You can see it goes in there. I think I did mention that what happens to most people is that the thing might default, if you don't do that, the thing might default to thinking you've got a grayscale image. And then if you've done a threshold and you try to display the output from the threshold on a grayscale palette, it'll just be completely black, because the ones and the zeros will just be looking black on a grayscale display format. So that's something to look out for. Another one that might be useful for the assignment is fill hole. And yeah, this is like a combination of dilations and erosions, I guess. Where you add pixels and then you remove them, but the system does it for you automatically just by calling fill hole. And kind of handy because, as I mentioned, if suppose you're looking for coins and you're looking for area of coins, if you have various highlights which appear as holes in the image, and that will alter the area readout and give you some errors, so you probably fill in those holes and then use that VI for that. And sometimes they change, they're continuously developing something like Labview, so they change the nomenclature and the exact name of these functions, but they retain functions that have useful functionality, and that's what we're talking about. Another one that's used a lot is the morphology analysis, and that's iMac particle analysis, where you put in an image and you get any number of measurements of the objects in the image. One of the more important ones, I think, is area. So particle measurements there, you see that on that there, it says particle measurements, that comes out as a cluster. You have to decluster it, if you like, because there's lots of values in there. Hayward circularity, irregularity, all the rest of it, size. Area is just one measurement out of a whole bunch, like center of gravity or position of the object. So you need to debundle it so that you can access that area typically, because you want to know what the actual size of the object is, most likely. Oh, here we have some of the stuff, for example. This is where someone's probably connected to the particle measurements output there and just collected it and selected an indicator, and it's coming up with all this information, as you can see, about different parameters associated with all the objects. And actually they appear as an array at the bottom of the screen, and if you click on a given column, it will sort of highlight it, and then the object that it's relating to is also usually sort of shown on the screen as highlighted. I think you did this in Vision Assistant, it's very similar, it just calls on particle array. So that's like a quick introduction to one or two functions that are built into LabVIEW that you might need for the assignment and find useful. So we covered, and I think we covered in previous weeks a little bit about what you can do with in terms of LabVIEW introduction. So I put this onto the internet, and hopefully you guys have had a chance to work through this. This is the first LabVIEW fundamentals. This is a tutorial I built myself out of bits and pieces. I thought, giving a nice introduction to it, less involved than some of the online introductions. You can go through any tutorials you want, of course. I'm not saying you're forced to go through this, but this is something I think people have benefited a lot from, to get a nice introduction to it. Giving you a lot of information about the icon and the connector pane. The icon, the way the thing will appear in the block diagram. Connector pane showing the way it will be connected up, like that. The terminals, the inputs and outputs. Typically, inputs will be on the left and outputs on the right. So it's worth just reading through this. I think most of it's just background information. But here at the end, there's an exercise where you can create a simple VI. These Americans have been a bit quaint, are concerned all the time with Fahrenheit, it seems. So we need, they probably want something that converts from Celsius to Fahrenheit, but I'd be more likely to want something to go from Fahrenheit to Celsius myself. But anyway, this thing is a little bit of a VI which you can create there, which does that operation of doing that conversion. So a little bit of editing in the block diagram to get that working. And there's another one. So it's another output, a thermometer type output, and a little exercise in relation to that. And Further work you can do, read voltage, simulating a voltage reading from the instrument. Just go through this at your own pace. You can create a sub-VI from sections of a VI. I think I might have mentioned this before, but you can just go to the VI and select part of it, and then turn that into a sub-VI. There you go. It's going from this complexity here in the original block diagram and turned it in, and that's been absorbed into this new sub-VI. But to be honest with you, you could just create yourself a VI and insert that there. You may not want to need to use that. So this is part of the basic tutorial. If I just go back to show you another quickly. So that was that was actually there's basically two fundamentals tutorials. That was actually number 2. This is number 1, which is the basic fundamentals, giving you a background on exactly what Labview is and just explaining what the block diagram and the icon is. And this is the first one to work through, of course. But with this one, you're just reading through and getting mostly background information on basically what the icons are, how the thing's presented, and how it works. And then towards the end of this is where you create the simple little VI, a virtual instrument, which does the conversion of the degrees Celsius into Fahrenheit. And basically, this is a little VI, and that shows our block diagram there. And this is the one that you then save and then you use in the other tutorial, which I was just showing you a second ago. So this is basically the very basic introduction, and the other one is following on a little bit about how you connect things and how things work. And it's just worth reading through this, of course, general background information. Broken wires, for example, there. Broken wire appears as a dashed black line, as shown in the following example. Broken wires occur for a variety of reasons, such as when you try to wire two objects with incompatible data types. Yeah. You can just delete that broken wire by selecting it, hitting the delete key. Edit exercise. This one is where if you might have already done this, where you load an edit exercise. I put this onto Blackboard for the VI for this, and then you just rearrange it according to how they think you should be rearranging it to make it a bit more ordered in certain ways. It shows you how you can move things around on the front panel to make it more ordered and make it more in line with what you might expect. So that's a couple of basic tutorials that I've put onto Blackboard you've probably already worked through to some extent. But if I now go to another document which I put on for one of the tutorials, which I think I call Tutorial 3 for historical reasons probably. The idea of this is that you build your first little VI, which is going to be hopefully something that you can base the assignment on. When you come to do the assignment, then you can base it all on this. So we could start from this. I find it helpful in this way to have something to start with, really. So what we're trying to do here is to create this VI, which will basically display an image. So not surprisingly, it uses the VI such as I might create, and then read from a file, and then this is telling it what file to go for. And then we got wind draw on the end here. So if I just think about how I might create this in Labview, if I just go to the Labview block diagram, I've also got a front panel. So in the block diagram, what I want to do, I want to start, you can do this, you can approach this in various ways. What I recommend is that you start off by putting the major sort of icons down, the major VIs you're going to use in whatever you're trying to do. So in this case, we said create an image, didn't we? Now one thing you can do is you just right click anywhere in the block diagram, and up comes the functions menu, showing you all these different VIs that are available to you. Now because we've bought and got the vision modules there, we should find them available to us. Vision and motion, iMac, you go see, just different iMac function, vision utilities, image management. There's iMac create straight away. So I'll put an iMac create up on the screen. There it is. Now you can image name. Now as I say, if you right click here, now there we've got context help on. Of course, there's a context help telling us what it's all about. Click on that. A bit more detailed help, which is often very useful. I use it all the time, that really. And, very, very useful. But and also, of course, when you hover the cursor over the icon, you see that the contacts are actually appearing. And then I get a bit nearer to them and I see that the cursor's turned into the wiring tool automatically. And it's telling me also what the name of these contacts are for these icons. So border size, yeah, entry. If I go to image name and I right click, I can do this create thing I was talking about. So if I can create, I can just call it a constant, keep things simple. And I just type in there some name or other for my image, call it whatever you want. So there we got now the image has got a name. So what's the next thing I want to do? Well, I guess I want to open that, I want to open that file. So if I just go to search, I don't know if you saw that I clicked on search there, the top there, a very useful function is search. So I'll just search for a read file. And it's called iMac read file actually, because it's there for reading in images, image files. And so if I just move that one and put it up there, we've got iMac read file. This is reads an image file. The file format can be a standard format, bitmap, TIFF, JPEG, as you might expect, or a non-standard format. Now, the next thing I want to do, as I say, is display this image. So again, I go to Vision and Motion, and I'm going to Image Processing. Oh, there's all these different functions here, very useful. Vision Utilities. But I go to Vision Utilities and I see External Display, and I go there. And the most straightforward one to use is iMac Display. So that's the basic one that's used in Vision. So there it is. Now this file dialog one, it's an input. And there we go. I'll just stick him up there. This is so it says configure file dialog. It's a file for a new existing type of file. So this is what they call an express VI. So a few years ago they created these new VIs, as I say. So we've got an express VI. So what do we need to do? Image type. I can just hover over that and create control for that, image type. Now if I double click on that, you'll see it's corresponding in the front panel to a control where I can control what type of image it's going to be, and it starts off by saying it will work for a grayscale image, which is fair enough for me for what we're trying to do here today. Now down the bottom here, the error control coder, you can just connect this up, and this controls the errors that are displayed to you, and it's kind of useful to do that. Now I'll just get that. And if I just click over here and right click again, I do a search for error. Yeah. I should get, actually I should appear here as well. There's normally, we normally got the error controller appearing in the dialog box here. What happened there? Just go back. Error. We just want a simple error controller. Oh, one minute. Anyway, if I maybe I'll worry about that a little bit later on. Just get the basic stuff sorted out first. And if I just connect to this, if you see here, file path, right? That's asking there for the file path that that this README file is going to use to look to get the image that it wants. So if I connect that to the so the file path, that's the connection with the output from this dialog box. So if I connect that to there, that's being okay. Now here, the image is being created here, and there's it says new image. That's it. And then this has to go into the image input there. Now this image that comes out with once it's had the file read into it, will then go to be displayed. Now make sure you don't get the right. Make sure you get the right one here. It's got to be imaged into there. Now I should do an iMac dispose, but I won't do that right now. I'll just simply get this working like this. So this is a very, very basic little program for just getting an image displayed. If I try and run it now, as you remember, the arrow key is run. So I run. It's asking me where the image is. Well, I got the image here on the desktop. And there we are. That's the image I wanted to display. So this is just a very, very simple introduction to how you use iMac and how you use the vision tools to display an image. Once you've got that image displayed like that, you can start now, of course, experimenting a little bit. You can start putting things in here to alter the image in various ways, and then seeing what effect that has on the image out. For example, you might want to put a threshold in there, for example, and see what effect that has. We can have a go at doing that. Let's see. So it's getting rid of those. I'm just deleting those. I'm going for the image again. Going for the vision and motion, image processing. Go for image processing. So image processing. iMac threshold. Start off with something nice and simple. That's why I like doing this, because you start off with something very, very simple like this. You're getting results. You're sort of enjoying using Labview. You're getting into the way it works. You're building up some confidence that you can actually use this thing. And you're also doing something which you can develop and further and work on to build up the assignments. This is where I recommend working. So do something, get it working, save it, play around trying to do additional functionality. If that doesn't work, you go back to the thing you saved and you keep on doing that all the time. This will be the way to slowly get somewhere, really. Now range, if I click on that, right click on that, and create a control, you see that it's created this control here. And there we have it. And that's what it's done. It's created these values which you can enter in there according to what you want to do for your. So I just need to send the image in there. I need to put that image in there, and I need to get that image out and display it. Okay, so we should be able now to run this and see what effect it has on the image. So up goes window. If I want to show the front panel, I just do that, of course. Now we have our controller, and we can just move this around a little bit. Move things around according to how you want. Put controls, outputs, inputs, outputs, whatever. I'll run this thing, and again we're looking for the, and it's showing it black. This is the problem that I mentioned earlier, which caught me out years ago and catches nearly everybody out. But what we've got here is a binary image where the system is trying to display it as a grayscale. In fact, that's what a binary image looks like if you look at it from a grayscale perspective. 1 and 0 is not something you're going to be able to differentiate between on a scale of 0 to 255. So we need to go back into this thing and tell WinDraw that we're actually going to display a binary image. So I'm right clicking again. I can just do a search, hopefully, to get palette. Get palette straight away there. iMac get palette. iMac is the name of the image processing toolboxes. So iMac get palette, I'll move it in there. And we'll just put that straight in there, into there. And if I go back to the front panel, actually I'll go back to here for a minute. I can control the way this thing operates. So that's the way it works in Labview, you see. It's a hierarchical system. So if you have any VIs, which are appearing as icons, you can just double click them and you get, and that's how that VI for get palette operates in terms of the front panel. And there's a block diagram for it. This is get palette. So you can keep on clicking up and down to see how different things work and at different levels, I guess. Yeah, so you can try running this again. Still getting black at the moment. We can investigate further. Yes. Yes. The important thing is not to get frustrated and not to worry about making mistakes, because the way you learn from these kind of systems is, of course, to actually, what you need to do in a situation, if you find yourself in a situation like this where things aren't working exactly as you expected, then what's going on? The first thing you've got to ask is, what's happening with this new VI I just put on the page? Why isn't it doing what I expected? Well, a lot of the time you just look at control, context help. And here, if I click on this, I can do my right click again. It says palette number. I could create a control. And there's the control. You see, it's appeared it's appeared on the front panel, and there we have it. Now, if I hold down, you might remember, if I hold down Shift and then right click on the front panel, I get this menu comes up which alters the way that the cursor works. So this is moving things around, this is wiring, and this is operating. So I want to operate this thing. So I want to get binary. Okay, so I should be okay now with my binary palette. I can select different types of palette here, all sorts of different types of palette, but the two I'm relevant to us here are grayscale and binary. I'm interested in binary for this. So again, I'm trying again. And now we're in luck, you see. I can run it again. I keep running things, doesn't matter. Just keep trying different things all the time. Now we're in luck. We've got, the way this thing works is that, the way this one's been configured, is that it's showing the thresholded, as you might remember, red or blue, depending on the exact version that you're using, is a way that it shows the thresholded sort of values have been set to 1 when you display it. But you can mess around with the values of the threshold to see what effect that has. And you can try it yourself to experiment with different things. What you can also do here, of course, is you could put in here, after you've done this threshold, all sorts of morphological operators. Again, we look at vision and motion, look at image processing, morphology. These are ways of measuring different things or doing different things. Well, it's not so much measuring in this case, it's more like doing different things to the morphology of the image. If I did want to measure, I'd go over to, these are filtering and distances measuring, I'd go to analysis. You can get a histogram, I talked about that. Find a centroid of something, which is a centre of gravity, if you like, the average of all the pixel locations. This particle analysis is very, very useful, okay, because if I just put that on the screen a minute, and I put context help on, I mean, this is where you get all your information. I was talking about this before. You get all your information. So I could put particle analysis in there, and I could get these readouts, particle measurements. I could create an indicator to show what I can do with all these different particle measurements. So that would be something that's definitely worth playing around with from the point of view of the assignment. And what you can do, of course, is you do things. You've tried Vision Assistant and found that to be probably pretty useful and easy to use. So you can go through, finding out exactly what you want to do, or experimenting with different VIs from pull-down menus in real time, finding an easy presentation. It's right there in front of you as you're using it. You don't have to compile programs or anything. And then when you discovered what the kind of approach you want, you can then implement it in your Labview VI. You get the at the bottom of the screen it tells you what VIs you need, what the parameters you need for with them is, and then parameters are, and then you can implement them in Labview. And of course, the great advantage of using Labview like this is that we can make use of while loops and all that kind of complexity in terms of program operation and control that we can't really do from something like Vision Assistant. Vision Assistant is good for finding out basically what kind of processing we might want to do, but actually doing it, especially for an automated system or an interactive system that the user can interact with, you're going to most likely require to do a little bit of programming in terms of looping and in terms of other types of control. And so that's an introduction to that, and I can't overemphasize the importance of you just trying to do different things, applying different kind of VIs, exploring all these ones that are available, seeing what they do. There's a couple of things I want to mention actually while I'm here that I think will be very much worth mentioning for you, and that is basically a couple of things you can do in programming. While we're talking about programming, a couple of things you can do in Labview that really will help you with the programming, I could just make a quick note on here. Now, I think I've got it up here. So the first thing I should mention perhaps is the shift register. Now, when I started learning this back in the 90s, there wasn't anybody around using this at UWE, and I had to find it all out from scratch. But basically, counting in Labview is not necessarily that easy to implement, you might think, because the language, the G code, is not recursive, or at least it's not as far as we're concerned on this course. It's not recursive, so that means you can't call itself. So you can't say let A, in BASIC you might have A as a variable, you might say let A equals A plus 1, which doesn't make any sense from a logic point of view. It's a recursion, it's a call to the self of the code. But the way you do that in Labview is to use something called a shift register. So this is one that's been implemented on a while loop. So as it says, so a shift register is usually part of some type of loop and is used to store values across loop iterations. So the values computed in one iteration are not discarded and can be used in the next. To make a shift register, you will first need to have constructed a loop structure of some sort. It's, for example, a for loop or a while loop. Once you have a loop, right-click on the right or on the left or right side of the frame. And so in other words, you have the cursor here, you get over here and you right-click and you select Add Shift Register. It adds two boxes. These are the boxes here. On the left side and on the right side, and with up and down arrows, as illustrated here. On the first iteration, the shift register on the left will produce 0 on the first run. By the way, I would connect that to 0 to make sure it does that, to make sure there's no doubt about it. And on the first run, unless a constant is wired to the default value. Make sure to connect a constant to the left shift register, as I was saying, to guarantee that the shift register is initialized to the same value for each run. If you do not wire a default value, you might be all over the place. You wouldn't necessarily know what's happening. So during the execution of each iteration, a value will be computed and put into the right shift register. This value will then be stored in the left shift register on the next iteration. So there's a way of remembering what a variable was doing, if you like, not a variable, but a value coming out of the program was doing on the previous iteration. Okay, little note on errors there. But this is very, very useful, okay, because what this does in this case is count to 100. Because this thing starts at 0, it does one iteration of this loop, and then, as you can see, adds 1 to it, you get 1. 1's remembered over here. In the next loop, it remembers that 1, it adds 1 to it, and you get 2 coming out. It keeps doing that. This thing makes sure that you only do 100 iterations of this while loop, because it says, when they're equal, it will stop the loop. It's a comparison Boolean operator. It's a comparison logical operator, and this is an add as an arithmetic operator. And this thing operates by means of Boolean. When I said Boolean, I mean Boolean is when it gets a false, or a plus, depending on how it's set up, either true or false, it will stop the loop. But when it gets to 100, it stops counting. So it just counts, and variable values come out 1 to 100 in this loop. So that's what I want to talk about here. It's definitely worth using these. Don't use variables if you can avoid it in Labview, because it's not designed for it. It uses lots of memory up, and you can set up race conditions quite easily. where you have, a variable A doing something, variable B doing something, you don't know which is going to happen first. But with this, it's the way it's designed to work, and this is the best way of doing it. You can have more than one shift register in a given loop, and you want to keep them separate so they're clearly not connected. Because another thing you can do is look at iterations, values of that value several iterations ago, and this will appear as different square blocks here. And you want to make sure you don't confuse that with having more than one shift register. This might sound all a little bit esoteric at the moment, but when you start using it yourself and actually playing around with it, just doing this simple thing to start with, the penny will drop as to how it works and what we're talking about here. So give that a go, shift registers. The other thing I want to talk about is auto-indexing. Now this is quite a handy thing whereby you can create an array out of a loop just going through a certain number of iterations. So if you wire an array, well, let's take this simple one here actually. You've got a loop. This is a for loop. It's going through 6 iterations, and this is the value of the iteration. Each iteration, this dice kind of icon, is a random number generator VI. So you connected that to the output of the for loop, the output there. You can see that the wire coming out is thicker than this wire here. This is because the way these things work by default is that if you run this 6 times with 6 random numbers being generated, the thing will output at the end of those 6 iterations an array of 6 numbers, and that's then going to be displayed there. Now, another thing you can do is you can just connect an array into a for loop, and then it will go through the for loop as many times as there are values in that array, and each time a different value will be presented to this node here, which is kind of handy for going through a whole loop. Going through a whole array. It's an easy way to look at all the values in an array. You can also build 2-dimensional arrays with it, which is explained here, by putting a loop inside a loop. So it goes through that loop, creates the first array of 6 numbers, then that's going to be one row for the next 2-dimensional array, if you like. You could arrange it that way. So this would end up with a 6x4 2-dimensional array with these 2 loops. You can disable auto-indexing, this is worth knowing. Disabling auto-indexing by right-click on the tunnel and select Disable Indexing from the shortcut menu. For example, disable auto-indexing if you need only the last value passed to the tunnel in the previous example. So this is worth reading through and trying again, just doing these simple little VI operations to get this working. By default, auto-indexing is turned on, for example, on for arrays, probably not on while arrays. So that's worth knowing. If you start off with a for array, it's going to automatically create this array for you. If you start off with a for loop, it's going to create the array. So that's just something that's worth knowing about these auto-indexing. These things are a little bit not so obvious, so I thought that's why I go through them in a little bit of detail. And you can look up on the internet you can look up on their help, of course. I would very much want to emphasize the importance of using the help in Labview. There's quite a lot of help there. And for simple things we're talking about here, you'll find out how to use them. The little example programs that have been provided. Have a look on ni.com as well, because there's loads and loads of useful information on there. But there are simple little programs people have written to demonstrate various different things, and these are worth going through. Just getting little things working and trying and seeing how they work, changing certain things and seeing what effect it has is a good way of learning about these kind of capabilities in Labview. So, this has been a little introduction to some of the VIs that are useful for learning about Labview, and especially for undertaking the assignment, which I hope has been a bit useful for you. I wanted to very much talk about a few aspects of things like auto-indexing and so on, because these are the kind of things you might need to use in the assignment program, of course, and the shift register. And also, I wanted to just show you a little simple program that just takes data from a file, and then displays as an image, and it looks for a certain file for you. Because when it comes to the assignment, you will be writing a Labview program. Labview program will be trying to run it. I'll be trying to run it, me and Abdul. And when we run it, you'll need it to make it user-friendly. You know, the thing will automatically come up with a dialog box asking us to select a file, for example. We'll select a file, but however you want to arrange it. I'm not telling you exactly how to design the assignment because that's all part of your style and how you'll present it. But this kind of functionality and these kind of things are very useful starting points for you to develop what you need to do, I think. So I hope that's useful. That's a little introduction on Labview. We're going through some more machine vision stuff most likely next time, and I'll see you then.